Welcome back, dear grade 9 students, to more training exercises about algebraic expressions. In this video, we are going to continue training exercises about algebraic expressions to make you more confident in factorizing, expanding, and solving algebraic expressions. So here we have p of x that's equal to x plus 2 into x squared plus 8x plus 16, and q of x as well is equal to x cubed minus 32 plus 2x squared minus 16x. First of all, we have to factorize each of p of x and q of x, and then we are going to solve the other parts part by part. Let's start and let's go ahead with factorizing each of p of x and q of x. As you know, first of all, in factorization, we think if we have to take a common factor, if we can take a common factor. Is there any common factor among these two? I guess no, there's no common factors. So we start thinking of applying identities, and as you know, we have three identities. The first identity is when we have a squared minus 2ab plus b squared, we are going to get, notice we have three terms, we get a minus b, all of it squared. And similarly, if we have it the same but we have plus in the middle, so we get a plus b, all of it squared. And if we have a squared, that's what we call the difference of two squares, minus b squared, then we will get a minus b into a plus b. And that's what I mean by applying identities. Now let's think if we can apply one of these identities here. Yes, we can. X squared plus 8x plus 16 is definitely coming from x plus 4, all of it squared. So we just look at the extremities of this factor. We take x squared, the radical of it, which is x, and the radical of 16, which is 4. And thus we are going to have p of x equals x plus 2 into x plus 4 squared. Now, what about q of x? Let's search if we can take a common factor among these four terms. Here we have x, here we have x, here we have x, but here we don't have x, so no common factor to be taken. No identity as well. No identity can be applied on q of x, so we start thinking of grouping. So grouping is based on taking 2 by 2 and taking a common among them. That's why I'm not going to take these first two together, because not common in between them. So I'm going to take the first one with the third one, the second one with the fourth one. So that's how grouping works here. We take x cubed plus 2x squared, and we take minus 32 with minus 16x. Among these, we have x squared as a common factor, and among these we have 16 as a common factor. But notice, because we have a minus sign here and we put the parentheses, we have to change the sign in the middle. So we are going to get now x squared outside. We take x squared as a common from these two, and x plus 2 inside. We take 16 as a common from these two, and we get inside 2 plus x. Now we can take simply x plus 2 as a common factor, because x plus 2 and 2 plus x are the same. So we take x plus 2 as a common factor, and what remains inside is x squared minus 16. Now x squared minus 16 can be also factorized using this identity. So it will be x minus 4 into x plus 4, and thus q of x is written as a product of three factors. Now let me tell you a note. If we have, for example, x squared into x minus 2, and we have plus 16 into 2 minus x. Now to take the x minus 2 as a common factor, we have to reverse this one. We have to write it x minus 2, because there is a minus in between the terms 2 and x. But because we reverse it, we have to reverse the sign also. So if it is a plus, it's going to be minus. And if it is minus, it's going to be plus. So please keep this note in your mind whenever you have a minus in the middle. But since here you have plus, no need to reverse and no need to change anything. Now, in this part, in the coming part B, we have to solve p of x equals 32 into x plus 1. Usually we think of taking the factorized p of x, but notice that if you take the factorized p of x and you take this in the other side and then take it to the other side and you are going to search for a common factor to take, you don't have any common factor. So let's think of taking the expanded p of x. To take the expanded p of x, we have to expand it as well. So x into x squared, x into 8x, and x into 16, as well as 2x squared, 2 into 8x, and 2 into 16. So we are going to get what follows. X cubed plus 8x squared plus 16x plus 2x squared plus 16x plus 32, the result of expanding p of x. In the other side, we introduce 32 into x plus 1, so we'll get 32x plus 32. Now we can add 8x squared and 2x squared to get 10x squared. 16x and 16x give 32x, and here we have 32. Now this 32x will cancel this one, and this will cancel this one, or we take them to the other side and we're going to get 0 on the other side. So what remains is x cubed plus 10x squared equals 0. Now we start thinking of factorizing again, because we have 0 in the other side, so we have to write as a product of factors to get one of them, each one of them equals to 0. So we take x squared as a common factor, and what remains is x plus 10 equals to 0. So either x squared equals to 0, which means that x equals to 0, or the other factor, x plus 10 equals to 0, which means that x equals to minus 10. And these are the solutions for this equation, 0 and minus 10. Now in this part, we are going to talk about rational forms and about the domain of definition. Here comes k of x, that's equal to q of x over p of x. So we take the factorized q of x over the factorized p of x. For what values of x is this rational form defined? It's defined whenever the denominator is not 0. So x plus 2 should not be 0, then x should not be minus 2. And x plus 4 squared, or x plus 4 as well, should not be 0, then x should not be minus 4. That means, because if I evaluate minus 2 in place of x, I will get here 0, and 0 times anything is 0. So if we evaluate minus 2, if x is equal to minus 2, then the denominator becomes 0, as well as if we evaluate x and we put minus 4 instead, then the denominator will be 0. So the excluded values are minus 2 and minus 4, so the domain of definition of k of x is R minus these two values, which are minus 2 and minus 4, or we can write it as follows. We say that k of x is defined, so it is defined for all real numbers except, so all real numbers except minus 2 and minus 4. So that's the domain of definition of k of x. Now, k of x, after simplifying it, after maintaining its domain of definition, we can simplify x plus 2 with x plus 2 and x plus 4 with x plus 4, and what remains in the denominator is just x plus 4. So after simplifying k of x, we get k of x equals to x of minus 4 over x plus 4. That's the simplified k of x, and let's see what we have in the coming part. We have to solve k of x equals minus 3. We have to see if this equation has a solution. So all what we have to do is to put the simplified k of x equals to minus 3, putting it over 1. So we put minus 3 over 1. We cross multiply. Then we'll get minus 3x minus 12. So we multiply minus 3 by x plus 4 equals to x minus 4. Now taking x to this side and 12 to this side, we're going to get minus 4x equals 8. Then x equals minus 2, which is rejected. So this equation doesn't have a solution because the resulted value is minus 2 and minus 2 is rejected. So we say that this equation doesn't have a solution. Let's continue the other parts. And finally here we have to evaluate k of 5 minus radical 9. Before starting by these and before making rationalization and so on, we have to search for simplifying this value. 5 minus radical 9 means exactly 5 minus 3, which is 2. So all what I have to evaluate is k of 2 and not that stuff. So k of 2 is just by replacing x by 2. K, if we remember, k of x was x minus 4 over x plus 4. So x minus 4 over x plus 4 means I have to replace x by 2. That's what k of 2 means. So I have to replace x by 2. Then 2 minus 4 over 2 plus 4 means minus 2 over 6 means minus 1 over 3.